Now let's talk about literals. As you know, literals are actual values like a 0 or a negative 3.65. Now, for numeric literals, there are two. There are integer literals and floating point or decimal literals, right? Integer literals examples being 2 or negative 189. Now, these obviously do not contain a decimal point. Floating point literals do, examples being 3.14 or negative 11.5. Now, there are two notations for um, floating point or decimal literals. These are um, fixed notation and scientific notation. Now, fixed notation must contain a decimal point, and these examples here represent a fixed notation. A scientific notation you'll be familiar from your math classes is as follows. Here are a couple of examples. And these are particularly useful for representing very large numbers or very small decimal numbers. So here's a very large number, 3.67 times 10 to the 17th. This is 367 followed by 15 zeros here, and but can be concisely represented in C++ with by 3.67 E17. Right? A very small numbers like this number like this one, 5.89 times 10 to the negative 6, a very small number here indeed, can be concisely written as 5.89 E minus 6 in C++. Now, there are other kind of literals besides just the numerical ones, and we'll go through three of them. There are character literals. Now, characters are enclosed in single quotes, and they look something like this. This is a character for capital Z. These could be lowercase. This could be numbers or special characters like asterisks or exclamations, right? Um, and the above statement here prints the character capital Z. Now, string literals are a sequence of characters, right? And these are enclosed in double quotes. So here's a string literal that it contains hello there exclamation, and the above print that string. Boolean literals have two possibilities, only two possibilities. It is true or false. Note that these are all in lowercase and you can print them as follows. Now, true and false are keywords or reserved words, right? And they can't be used as variable names. Interestingly enough, if you execute this, what you will see is 1 printed for true and 0 printed for false, because internally that's what they're mapped to in C++, right? Sometimes you'll see literals referred to as constants, right? And variables that hold literals that do not change, need to have the const modifier. We've talked about that in earlier lessons.